Welcome to module 19 of Database Management Systems course in the IIT Madras online BSc program. We have been discussing the database design process and we have taken a look at the basic premise of the design and decided that we are initially focusing on the conceptual design or the logical model of the requirements. And for doing this, we are learning a framework for this modeling, which is entity relationship model in terms of entity sets, attributes and relationships. So, in the module in this current module, we will learn the representation of these ER models in terms of a diagram known as ER diagram, entity relationship diagram, and then we will see how this diagram can be translated into relational schemas or tables. So, these are the two main things to discuss in this. So, ER diagram. ER diagram is a diagrammatic way to represent all the information that we have talked about so far. Now, this is something which evolved at the very early stages of database design, and the notations were somewhat different at that time, and at the end we will we have listed those alternate notations which you might find in several places. But over time it has evolved, and with the introduction of a very powerful modeling framework known as UML, Unified Modeling Language, these have got standardized now kind of in a certain diagrammatic way. So, through this we will see how to represent attributes, how to represent entity sets, how to represent relationships, how to represent cardinality and so on and so forth, lot of things. So, entities are typically represented like this is a rectangle and which has the name of the entity set, and then you have the list of attributes one after the other, and the key of the entity set or the attributes that form the primary key of the entity set are underlined. So, you can see what is a instructor and student and so on. And if you look up in terms of UML, you will see that these are notations which are typically embedded in the class diagram set of diagrams in UML, and with the added information that every attribute there will not only have the name, but will also have the type specified. They go another level further, but we will for now just keep to the ER model part of it. So, this is how you represent entity sets. Now, between two entity sets you can have a relationship which are shown as diamond, and in the middle of the diamond you give the name of the relationship and you connect the entity sets through lines. And implicitly it means that advisor is a relationship between instructor and student, and the relationships, unless otherwise specified, will mean the relationship between the key of the entity set on left and the key of the entity set on right. So, advisor will have instructor.id and student.id, this pair to work with. It is possible that we talked about that it is possible that the relationship itself has an attribute. So, if it has, if the advisor relationship has a date, say from where the advising process has started, then that attribute is directly connected to the relationship through a dashed line. Dashed line means that this is not a relationship line, and because if you this is a diagrammatic language, right. So, the symbols and notations are very important. For example, if you make this what happens if you make this a solid line? If you make this a solid line, then that will mean that advisor has a relationship with the entity set date. Now, that will mean an entity set which has no attribute. Possible? I am saying as an entity set which has no attribute. I have not yet decided on the attributes, but there is a relationship with date. There is a concept called date through which it will have a relationship. but that is not the case. We use a dashed line. The moment we use a dashed line, it does not mean a relationship with an entity set. It means that this relationship has an attribute. So, date now is interpreted as an attribute, and it is an attribute of advisor. So, advisor will now become triplet instructor.id student.id date, right. So, remember. Be careful about the notation. Then the roles, entity sets in the relationship may not be distinct. An entity set may have a relationship with itself. For example, course ID and prerequisite we have seen. Every prerequisite is itself a course ID, right. So, prerequisite is a relationship between course and course, where naturally how do you distinguish them? Because you need two. So, on the other side, on one side you call it a course ID, on the other side you are calling it a prerequisite ID. You are giving a new name, because it are two instances of the same relation. So, by name it is the same course.course ID, course.course ID. So, kind of here you make use of the renaming concept we had used. So, whatever is a prerequisite you call it the prerequisite ID. So, you say that an entity here in the relationship prereq is between a course ID, which has a role of defining the course, and a prereq ID, which is actually a course ID, but has a role of specifying that what is the prerequisite, right. So, this is a typical kind of model. There could be cardinality constraints, as we have seen. So, cardinality constraints are shown simply as if it is how the arrow ends. If it ends like this, it is many. If it ends like this, it is one. If it has an arrow at the end, then it is one. If it does not have an arrow at the end, then it is many. That is the basic meaning of the cardinality. So, you can very easily understand that it is saying that advisor is a relationship between instructor and student, and it is one to one, which means every instructor has only one student and every student has only one instructor. That is what is being said. So, if I do, which is more typical, that it is one to many, that every advisor, every instructor will have many students as advisee, whereas every student will have a unique. So, you have to see which side that arrow is. So, arrow is on the left side. So, instructor is one, student will be many. And obviously, when I say 1, it is possible that it is not existent. So, 0 is also, it is 0 or 1, I should rather say. This is many to 1, where this now says that a student may have multiple advisors, but every advisor will advise only one student. And you can have many to many, where every advisor may have multiple students, every student may have multiple advisors. You can see that there is no arrow on either side, right. So, these are how the cardinalities are shown. Then the question of total and partial participation, we just talked about it in the last module. So, when you have a total participation of an entity set in a relationship, you show that by a double line. So, the advisor line has a double line connection with the student. So, it means that every student must participate in the advisor relationship. In general, as what I said, that is, it could be many to 1 means it could be 0 also, but that is not possible in this case. Whereas, or between the instructor and advisor, there is only one single line, which means that this participation is partial. So, an instructor may or may not feature in an advisor relationship. So, instructor may not have a student, but a student must have an instructor. So, this whole idea is getting modeled through this representation of total and partial participation. We discussed total participation in context of weak entity set, but it is a general concept which will be represented and used in multiple ways. Now, it is possible that instead of just doing one to many or many to one and things like that, you could actually specify the cardinality of a relationship on both sides of the entity set. For example, here on advisor it is showing 1 dot dot 1. So, this is a minimum to maximum. So, 1 dot dot 1, it says that it has to be minimum 1 and it has to be maximum 1, which says that it is uniquely 1, which says that it is total, right. That is whereas on the instructor side it is saying it is 0 dot dot star, star means anything, it is a wild card, no limit. So, it says 0 dot dot star, which means that an instructor may not have a student, may have 1 student, may have 10 students, may have 1000 students, everything is possible. So, this is a pure modeling of the many, and this is therefore, the moment you include 0, it means that it is possible that the instructor does not feature in the advisor. So, the participation is partial. Right. This is the notation for representing complex attributes. So, you write the composite attribute and then write the component attributes with a tab. So, name, this reads that name is an attribute which comprise of first name, middle name, last name. Address is a composite attribute comprising of street, city, state, zip. Street in turn is a composite attribute and so on. Right. Then note another thing that in the phone number, we have put the phone number within curly braces. Right. That means that this is a multi-valued attribute. You remember single attribute, composite attribute and single valued attribute, multi-valued attribute. Right. So, here in this we are showing the notation for composite attribute as well as multi-valued attribute. In the last, if you see age, you see a pair of parentheses after it, which is what? Which is a function notation, right. What do we write like this? Function notation, which means that this attribute has to be computed, and we discussed that age is a derived attribute, because it cannot be stored directly, it will have to be computed from the date of birth. So, that information of derived attribute is represented here. So, this is just one single slide which tells you what are the different ways information can be represented in the ER diagram for attributes, simple attributes, key, composite attribute, multi-valued attribute, derived attribute, everything is shown through this representation. So, just try to remember these. If you have to represent a weak entity set, naturally what are the conditions? You need a relationship between the strong entity set and weak entity set. So, first the representation of a weak entity set is done by using a rectangle for the entity set which has double line boundary. See, course has single line boundary, section has double line boundary. So, that double line boundary says the section is a weak entity set. That immediately means that section must be associated with some strong entity set through a relationship. So, that relationship is sec course. So, this relationship is linking a weak entity set to a strong entity set. So, to represent that, the diamond of this particular relationship is also drawn with double lines. You see, this is diagrammatic language, every way of drawing will mean something or the other. Right? So, we know that section is a weak entity set, course is a strong entity set, sec course is a relationship from section to course to define the weak entity set properly. So, since and then you see that between sec course and section the line connecting is double line. What does it mean? That this has a total participation. So, now you see that all of these conditions have been satisfied. So, what is remaining for the weak entity set? I need to know the discriminator. So, the discriminator is shown in the section entity set representation by doing dashed underline of the attributes. So, section ID, semester and year, this triplet is the discriminator, and this is underlined with dashed, saying that this is a discriminator, not a primary key. So, the section course will associate, sec course will associate this with the strong entity set course, whose primary key course ID along with this discriminator, that is course ID, section ID, semester and year, this 4 together will be the primary key of the weak entity set section. Right. So, this is a more detailed diagram of the university representation that you had seen. So, earlier it was just showing, well, this is there, that is there, this kind of. Now, it formally shows in terms of a ER model. You have to understand it very thoroughly and study it, get satisfied that all conditions that are being shown by the ER model actually what does it mean in the real world, whether it is kind of how meaningful it is and whether it is capturing the real world in the proper way or not. So, we will move to the ER model to relational schema, that now we have the ER model. So, here we had a concept, from that concept we form the attributes, entity sets and relationships. Then we have represented that without ambiguity in terms of the ER diagram. Now, we have to start creating the relational schema. The reduction, this is called reduction to relational schema. So, all that we need to do is primarily we need to know two things. One is how to show the relational schema for an entity set, how to show the relational schema for a relationship. So, it is very simple for a relational schema for an entity set is you just take the name of the entity set as the name of the relation and the list of the attributes as you have as the attributes. If it is a weak entity set, then you have to do this process of going through the identifying relationship of the weak entity set, the discriminator, the primary key of the strong entity set and get the primary key of the weak entity set, put that as a list using the name of the weak entity set as the relationship. So, it is very obvious how these relationships are now coming out. You will see that things just go in a very smooth way. Then is a relationship. In the relationship, as I said, by default the relationship between the primary keys of the relations that it is connecting, it is associating. So, here in advisor you have the instructor ID and the student ID. So, you say it is SID and IID, just names given. You can write it as instructor underscore ID, student underscore ID also. But the idea is you take the primary keys of two sites and put them as attributes. So, you can see that basically it is a very simple thing. You need to have what is a relation. A relationship is a name and a set of attributes and the information of the primary key. This is the three fundamental information for a relation, the schema. So, the name is coming from the name of the entity set or the name of the relation, and in terms of the attributes we are just figuring out how to get those attributes. In case of strong entity set, it is just a list of attributes. In case of weak entity sets, it is a list of attributes of the weak entity sets plus the primary key of the strong entity set through the identifying relation, and in case of relationship it is the sets of primary keys put together of the two relationships that it is, two entity sets that it is associating. Now, how do you handle composite attribute? There could be two ways to handle that. One is and that is what in most cases be done, is called flattening, that you instead of getting into the composite hierarchy as you have on left. So, instead of having name as an attribute, you will have first name, middle name, last name as three different attributes. So, that could be the unifying schema. The other approach could be that which in some cases will be used is, in case of a composite attribute, you will actually not represent the attribute here, rather you will represent the attribute as a separate entity. You will say make an entity set for address, then it becomes, or say entity set of name, then it becomes simple attributes. If you say name is an entity set, then these are simple attributes, right. And then you define a relationship between these two. So, it could be something of that, but typically what you will do is flatten. So, if I have done that in the instructor design, just ignoring the multi-valued facet of the phone number, you will see that we have the relational schema designed here. Now, how do you handle multi-valued? Now, if you have to handle multiple values, naturally you cannot put it right there. So, what you will have to do is you will have to create a separate entity set and have a kind of relationship with the original entity set, so that you can say that in the multi-valued phone number, what do we know? It is between the phone number and the instructor, what is the type of relationship? It is one to many. That is, one instructor can have multiple phone numbers, but one phone number cannot belong to multiple people, right. So, if I take the phone number by itself is a key, right. So, I can represent it in a table, in a relationship, in an entity set with the ID of the person who holds that phone number. That becomes the relationship of using number, which number am I using, right. So, that could be a way to, so that is why you see that inst phone is a doublet of ID and phone number, by which we can now have multiple phone numbers associated with this, but obviously this means that there will, while we want to extract phone number, there will have to be some additional logic in the processing, because it is no more just a flat attribute, but it is coming through a relationship in the process. Now, many to one and one to many relationship sets that are total on the many side can be represented by adding an additional attribute. For example, what we are saying, say we have here, let us understand this diagram again, 3 entity sets: instructor, department and student, right. 3 entity sets: instructor, department, student, and 3 relationships. One is advisor, which is many to one from student to instructor. The other is the student department, that is which department does a student belong to. This is also many to one, but with the specificity that on the student side this is total, which means that I cannot have a student who does not have a department, right. It is a total part. So, every student must be there in the stud-dept relationship, which means that no student can be there without a department. Then the inst department is a similar relationship, but between the instructor and the department, again that is also total. So, if every instructor is to, so what is, say what is the student dept relationship? This relationship is, if I, when I put it into the relational schema, it becomes department name and SID. both of them together is the key, that is this relationship. And this one is department name and IID, both of them are key. Right. Now, the point is, since from the many side this is total, which means that for every IID there is an entry in this, and it is many to one. So, that entry is unique. Two things. One is every IID will be there in this, and it will be there only once, right, because it is many to one, it can have only one department. If that be the case, then the question is, do we need this relationship, or simply I can take the department name and put it as an attribute here. Similar argument will say, do I need this, or I can take it and put it just like here. So, I can just extend the instructor and student entity sets or relationships by an additional attribute department name and get rid of these two relationships, which will be two different tables like this altogether, reduces my overhead of doing traversal join of relationships in answering the query. Right. So, that is some of the considerations to scrutinize after a basic design has been made. So, this is also something that you can look at. You can take this also is from many to one. This is on the section side, this is total. So, section will be there in sec course only once, right, it will be unique, and every section will be there. So, we can include course ID in the section, that is in terms of modeling the weak entity set. Now, we are saying that weak entity sets discriminator, then the identifying relation, then the key, primary key of the strong entity set. After all these, I can just take the key of the strong entity set and put it in the weak entity set to make it a strong one and get rid of the identifying relationship. Right. So, if you now go back and see the schema that exists in that we had been using, you will see that because that was a relational schema. So, now we are slowly evolving and trying to come to that schema. So, you will see that this kind of considerations have gone in terms of first designing it, refining it, and then removing the redundancy in a full blown form. So, this brings us to the end of discussions in this module. We have discussed the basic ER diagram and translation of ER models to relational schema, and we will continue in the next module. Thank you very much for your attention, and see you in the next module.